My name is Udo Shadia. I'm going to explain question 1 first. What is inheritance in Python? Inheritance is a key concept in object-oriented programming that allows classes, subclasses, or derivative classes to inherit attributes and methods from another class, superclasses, or base classes. Parent and child class. For this, parent class is superclasses and child is subclasses. For this facility called zoom and protect the concept of is a relationship where subclasses is specified a version its superclasses about being Python inheritance syntax. In Python, inheritance syntax is implemented by specifying subclasses in parentheses and after subclasses name in class defined. These subclasses then automatically enhance and attribute and method from its subclasses. Here, syntax as you see is like that. And then question C, inheritance subclasses function. The function in Python is used to call methods and the contrast of subclasses with the subclasses that are access method and that will be defined in the superclasses without explicitly naming the superclasses. This particularly used to invoking the superclasses constructed or calling overriding method as here syntax as you see like that. Now we have on question D types of inheritance in Python. Single, multiple, multi-level, and theatrical and hybrid. I'm starting with the hybrid. A hybrid inheritance is a combination of one of them like that. If we combine S, we are combine two or more to make these types of inheritance. About hybrids, there are multiple classes that inherit from single and superclasses. For that, we can combine two child classes must depend on one parent equal superclasses. About multi-level subclasses inheritance from another class. Create inheritance is a combination of subclasses which create inheritance. And multi-level about multiple is subclass inheritance from multiple classes. It's like one parent have child. And that's two child depends on parents. About single inheritance is subclasses inheritance from single parents. About this, it's like when you have child can depend on one parent, like parent and child. In example of these types in Python, Python, so it's example and that's Thank you. This is a group number 5. I'm going to explain the following question. First one is what is inheritance in Python? Inheritance is a key concept in object-oriented programming that allow classes, subclasses, or derivative class or child class to inherit attribute and method from another class, subclasses, or based class or found class. It facilitates code to use and promote a concept of iteration where subclasses it specify the version of superclasses. About question B, first of all, for inheritance, it's like when a child depends on parents. About question B, Python inheritance. In Python inheritance is implemented by specifying superclasses or parent class in parameters, and after subclasses, name in definition, the superclasses automatically enhance that attribute in method from superclasses. Here it's a syntax which can be explained. You can define the parent classes, and after then, as you say, must call a parent class which can be explained well. But question C, it types inheritance superclasses. Superclasses parenthesis function in Python is used to for methods and contribution of superclasses within the class to allow access methods and attributes to define in the superclasses without naming the superclasses. This particular used for invocating superclasses for abstract encoding overriding method here as syntax. You can see you must define this superclass with their statements, and also you can also define superclasses for the end. You can call superclasses. This can be explained very well for this about the types of inheritance. We have a single, multiple, multi-level, hybrid, hierarchical. I'm starting with a single. Single is subclasses inheritance from single parent. It's like when I have chart and that chart and depends on one parent. But a multiple subclasses inheritance from a multiple superclasses. It's like when we have one child and depends on multiple parents. About multi-level subclasses inheritance from another subclasses. It's like when we have a two child, a one child must be located in one side in another, and those child which are located on different locations must depend on one family, which is called multi-level inheritance. About hierarchical is a multiple subclasses inheritance from a single superclass. So like when you have a many children, and it also depends on one parent, but in same side. About hybrid, it's like when you're combining one, two or more types of inheritance. For example, you have take single, multiple. It can be made or also have this multi-level. It can be or combine this about and also you have the types of inheritance in Python. Have a syntax which can be explained where you can see you have like this, declare this and this. If you run, you can be this, you can get this reason. Lizard, thank you. And continue with the question B with another.
Hello. My name is Utaiwa Emmanuel. Now I'm going to explain more information about the homework with God. Now I can start on the second question, which to discuss about Python method override. In the Python override is a fundamental concept in object-oriented programming (OOP), where a subclass provides a specific implementation of the method that is already defined in its superclass. When an object on a subclass is used, the overriding method in the subclass is invoked instead of method in the superclass. This it's like to overriding is like to replace or to invoke to get the permissions on the superclass, the permission in the class using superclass. This used to connect child class to parent class by using superclass. Okay. Here are some key points about method override in Python. Inheritance method override relies on the inheritance relationship between classes. When subclass inherits from a superclass, it automatically inherits all the method of the superclass, including those that can be overridden. Some signature to override the method in a Python. The override method is the subclass must have the same name and the same number of parameter, include the default parameters as the method being overridden in the superclass. Here we have dynamic dispatch. In Python, the dynamic dispatch uses dynamic redispatch to determine which method to call based on the type on the object at runtime. When method is called an object, the Python interpreter looks for the method starting from the class of object and the travel of the inheritance hierarchy until they find the method definition. If the method is overridden, the purpose of the override in Python, method overriding is commonly used to provide specialized behavior in subclass. It allows subclasses to modify or extend to the behavior of the method inherited from their superclasses without modifying the superclass itself. Yeah. In this side, the superclasses superclass it help to define the specific class without identifying the parent class. Okay. And now I'm going on the third question, which is to discuss about what is polymorphism. The polymorphism in the Python, the polymorphism is a fancy way of saying many forms in any object-oriented programming OPP or OP. It's a powerful concept that lets you write code that can work with objects of different types. Here, a case of Python polymorphism. You define an interface like set of instructions that specifies the operations can be performed on an object. You create different classes in the implementation that interface, each providing its own unique way of carrying out those operations. Your code can then interact with object of these different classes through the common interface without needing to know the specific type of object it's dealing with. Okay. Let's deal with an example in Python of how the polymorphisms work. The polymorphism work, for example, like you have the class animal, which define make sound.
Where am I stopped? So let me start with discuss more information about encapsulation in Python. So encapsulation is a fundamental concept in object-oriented, which is also known as OOP, that brings data attributed methods that operate on data together with a single unit code. So, why encapsulation, or why we need encapsulation in Python? Encapsulation offers several advantages. Those one like data protection, modularity, information hiding, etc. So simply data protection is like how we prevent unauthorized modification of objects internally data, or modularity. This is making your code more organized and easy to maintain. So information hiding, this allows you to hide the internal implementation details of a class and expose the dependent interface for interacting with the object. So, how encapsulation is achieved in Python? So, encapsulation is achieved by using strict access modifiers like public, private, and protected. So here is an example. Here we use a class as a bank account. We have some codes to use. Many are like the codes we usually use, but you also use the hashtag of public method to access private balance, by public method to modify balance, by public method to modify balance expectation, etc. So let's go to the getters and setters in Python. So while Python does not enforce data access restriction, you can implement getters and setter methods to further control how attributes are accessed and modified. So here are some codes we use while we are using setters and getters. Here you can use single underscore for conversation, also setter and the getter methods with validation. So let me start here with how setter and getter are used in Python. So a getter method is used to retrieve value of specific attribute within a class. So by using a getter method, you can control the attribute value, how is accessed, and potentially apply any formatting of logical before returning it. So here are an example of how codes we use in getters. Here you can use self.name or self.age, and on the other line you can use setter for name, getter for age, or setter for age with validation. So here is an example of how we use setters, and here up are an example of code how we use getter. So after this, let's see together the benefits of using getters and setters. So first benefit of using getters and setters, the first one is encapsulation. So getter and setter promote encapsulation by controlling access to attributes and potentially adding validation logic during modification. Also, these getters and setters are used for data integrity. By validating data and setters, you can ensure that only valid values are assigned to attributes, maintaining data consistency. Also, this provides flexibility. Here you can customize the behavior of getters and setters to fit your specific needs. So thank you. That was our presentation. Thanks for your attention.